Okay, these notes are regarding MAT 1100 sections 3.4, 3.5, and 3.7. The section starts off with inequalities, as you see here on this page. You're going to be learning how to graph them, solve them, and then also take written verbal expressions and translating them into symbols that will include an inequality symbol. So as you see in these first two boxes, you're learning just basically which direction should I shade in. And I can tell you that as long as the variable is on the left, the way that the arrow points is the way that you shade. So this arrow is pointing to the right. You're going to shade to the right of 4. Okay, so you're going to go to 4, open up a circle there. You'll shade it in if there's a partial equal sign here. In other words, if it said greater than or equal to, you would shade it in. And when there's no partial equal sign, you leave it open, meaning that that particular number is not actually part of the solution set, but everything to the right is. When you come to this one, you're going to be graphing at -4 and less than or equal to that. So all values less than or equal to. Again, when the variable's on the left side, just look at the way the arrow points and you shade in that direction. Okay, that only works when the variable's on the left. So I would suggest you rewrite it like that just to help you be more successful with shading. So go to -4. This time we're going to color it in because there's a partial equal sign, and we're going to shade to the left because it points to the left of -4. That would be that way. Okay, here's a summary of all those symbols. Down towards the bottom of the page, you see written verbal expressions, and we're going to translate those into symbols. So this talks about a senior admission rate, which they said to use the letter Y for, so we're going to use the Y to represent that. It says a visitor must not be less than 65 years old if they're going to get the senior rate. So if you want to take this sentence and transform it into symbols, it would be the senior rate only applies if you are not less than 65 years old. So you can be equal to 65 years old, but you can't be less than that. That means you have to be greater than 65, and that would make sense. These rates are only available when you're 65 years old or older. That's what's considered seniors according to this sentence. In the next one, to be eligible for financial aid, a student, and for financial aid, we're going to use S to represent financial aid. A student must earn at most, the most you're allowed to earn is $20,000 a year. So we're going to say S, you can earn $20,000 or less than $20,000. If you're earning too much money, in other words, above and beyond $20,000, then you're not eligible. So what you earn has to be less than $20,000 or right at 27, or right at 20,000. Sorry. Okay, going to the next page, still on lesson 3.4. We're going to look at how to solve some inequalities. I put a little reminder down here for you that sometimes the direction that this inequality is pointing in, it switches while you're in the process of solving the inequality. That only happens if on your last step you either multiply or divide by a negative number. Then you're going to flip the direction of the inequality around. So I'll try to make that happen in at least one of these problems just so you get an example of when that's happening. In this problem, as well as this one, you're working on getting rid of fractions, and all you have to do is multiply by the reciprocal. So for instance, the number that's with this W is actually 1/7. That's why you're going to be multiplying by 7/1 or just 7. Don't forget, you're doing the same thing on both sides, just as if you were solving an equation. Now, all I'm doing is multiplying by a +7. So this does not apply. It's only when you multiply by or divide by a negative that the direction of the inequality flips around. So that would not apply here. It's going to stay the same. These 7s would cancel, leaving you with just one W or just W. Over here you'd get a 35. Let's say they asked you to graph, although I didn't ask you to graph here, you might want to, when you're going to graph, you might want to rewrite these with the variable on the left, the number on the right. Just make sure that when you do rewrite it like this, that you open it up in the same manner that you have right here. See the open part, the W is inside the open part. So make sure that you rewrite it just like that. Because when you put the variable on the left, then when you go to graph, you shade right in the direction that the arrow is pointing in, which is only true. Some students tend to get it wrong when they leave it like this. I'm talking about when they graph. So you might want to rewrite. Okay, if you were going to graph this, it would be circle, shaded, and then go in that direction. That's your graph. Okay, likewise here, you're trying to get rid of the fractional coefficient that's here, just like I was trying to get rid of the 1/7 here. So you can just multiply by the reciprocal of this coefficient, just like I multiplied by the reciprocal of 1/7. So 4/9. 4/9. The 9's cancel, the 4's cancel. This stays the same because I did not multiply by anything that's negative. All you have is the y that's here. And then when you go to do this part, it's 4 times -2 over 9. If you were going to graph that, again, you might want to rewrite it if you were going to graph it. Putting the y on the left, number on the right. It's probably the surest way to get the graph correct. The pointy part is pointing to the y. So make sure that when you rewrite it, you state it in the same manner. If you were going to graph this, you would just go to -8/9. Put your circle, decide whether you're going to shade it in or not. No shading here because there's no partial equal sign. And then shade to the left in the direction that the arrow points in. Arrow points to the left. Okay, now we get into inequalities where you need 2 or more steps to get to the final answer. In this one, we're going to first move the 9 over here. So that's step 1. At that point, we'll have a 2v because the 9 will be gone. And then 4 combined with -9, which you could always put in your calculator if you need to, is -5. So that was one step right there where I subtracted 9 from each side. My second step is I'm going to divide off the 2. This direction of the inequality stays the same. And then I get -5/2 for my answer. I'm not going to graph that one, but I'll graph this one. So that you have examples solving, graphing, and also I think in this one what I want to show you is what they mean by this. So I'm going to purposely make that negative happen. You do have the option if you were solving this to either get the y's over here or the y's over here. I like to get my y's on the left for graphing purposes, and it'll also give me a chance to give you an example of what they're talking about down here. When does the direction switch? So if I was to move positive 9y, I'd have to subtract 9y. This would still be in the middle. The y's would be gone on the right-hand side. All you'd have is the -14. 6 take away 9, -3. And then there's also that -2 right there. Okay, so at that point, I have the y's on the left. There's still the number -2 on the left, and I'd want to move that -2 over to the right. That would be -3y less than or equal to. The 2's would be gone at that point. Over here, you'd have a -12. That was my second step. So I subtracted 9y to get all the y's over here. Then I added 2 to get all the constants on the right side. And then my final step, here I am doing this, what I talked about down here. That on your very last step, if you are either dividing by a negative or multiplying by a negative, on that last step, that's when the direction of this flips around. And in other words, it switches to the opposite. We call that flipping. So instead of less than, it'll now be greater than or equal to. These 3's will be gone, leaving you with just the y, and you will get a positive 4 here. If you were to graph it, it would just be 4 greater than or equal to, and then to the right. And then one more expressional problem from section 3.4. It says Pablo has a tree in his backyard. I've seen this problem quite a bit on the tests, just like these are quite popular for the test. I mean, everything that I've given you so far here are things that you're going to tend to see, but these ones where you translate them into symbols, and this one as well. This would be a typical book problem that would appear on the test. Okay, it says tree grows 35 centimeters each year. That's that right there. And at the end, 22 centimeters are taken off of the tree, because this inequality is regarding the height of the tree. So 35 centimeters a year, X stands for the number of years you're allowing the tree to grow, taking 22 centimeters off the height. And in the end, you want the height of that tree to be greater than 258 centimeters. That's the goal that you're shooting for. This represents the height. It's growing at 35 centimeters per year with 22 centimeters taken off, and the goal is to get it greater than or equal to 258. So first, solve the given inequality. You'd have to add 22 to both sides. You'd have a greater than symbol. This would turn into 280. The 22's would be gone on the left-hand side with only a 35x remaining. To get rid of the 35, you'd have to divide by 35 on both sides. So you'd have x is greater than or equal to 280 divided by 35 is 8. Okay, so number of years, which is what the x stands for, the number of years that the tree is going to grow to achieve this goal of being taller than 258 centimeters is going to take 8 years or greater. So now you want to try and pick the answer that will allow you to fill in this answer as well as talking about the original inequality. Okay, so to meet the goal, the tree must be more than, you would put the 258 there, and you need an answer that's going to allow you to say that this will take greater than or equal to 8 years. So this can't possibly be it. To meet the goal, the tree must be more than 258 centimeters. This will take more than 8 years. Okay, so this looks like we could put the answer in here. This one's no good because it says to meet the goal, the tree must be less than 258. No good. It says greater than 258. So this is the one that you want to fill in your answer, that allows you to fill in what the original inequality is stating as well as your solution. This will take more than 8 years. So that's your answer. Okay, that completes 3.4. Let's move on to 3.5, where we are doing some problems with perimeter and area. Okay, so this first one is about perimeter. It says use all 5 sides in your first expression, simplify to get your second one. It asks you to write an expression that has to do with the perimeter. So when you do perimeter, there's no formula. It's just add up the sides in any order that you want. So I'm going to start with the 3 and make sure that I throw all sides into this perimeter. So it's 3 plus 9 plus 5x plus 4 plus 8x. And then when you simplify it, all you're doing is combining like terms. You'll put all your x's together. In other words, the 5 and the 8 combines to give you 13x, and then the constants are 3 plus 9 is 12. 12 and 4 16. And this is the simplified expression that goes with this. Okay, coming to the next problem, we talk about area. You have to know the formula for this particular shape. So it's area is equal to length times width whenever you're talking a rectangle. So they say that this rectangular parking lot, the area is 8,316. So right in here for area, you're going to put 8,316 meters squared. You can leave the units off right now. And then it is length times width. Okay, so let's see, what do they give you? The width is 84, so you'd be putting in an 84 right here, and the length would be right here. And you're solving for length. So if two things are multiplied together and you want to break them apart, you do the opposite of the way that they are presently attached to each other. They're attached in multiplication, so divide the 84 right off of there. Likewise on the other side. At that point, you'll be left with just length on the right-hand side. The 84s will cancel, and then you can put the 8316 into your calculator. You get 99. Okay, back to perimeter again. The perimeter of a rectangular pool is 316. If the length is 97, what is the width? For this one, you're going to probably like a picture, so you can understand what to do with 97 and the 316. So they're saying the length of the pool, let's let this be the length, is 97 meters. So therefore this side, because opposite sides are equal. What you don't know is the width. Then if you were going to continue this problem, you would want to write an expression, or in this case, an equation, like you began to do with this first example. So the perimeter would be two of these, which you could just write like this, plus two of these, is equal to a total of 316 for your perimeter. Okay, then you can get your calculator and start to work it out. 2 times 97 is 194, plus the 2W adds up to a total perimeter of 316. Your question is, what is the width? So you're solving for W. Okay, this number that is added to the 2W, the 194, you want to get that on the other side first. So subtract 194 from both sides. That'll leave you with 2W is equal to 122. And then to finish it, divide both sides by 2 until you get W is equal to 61. And that would be in meters. That's the answer to this one. Okay, last problem on this page. Jim is on his way home. He has driven 12 miles so far, which is 3/4 of the way home. 3/4 of the distance home. They're calling the distance home the total length of his drive. So maybe we'll use, for the total length or the total distance home, how about if we just use L? So now if we try to write an equation, again, just rereading these words, certain things translate in a certain way when you're trying to go from words into expressions or equations. So 12 miles is means equal when you're setting up an equation. So 12 miles is 3/4. This is how you write 3/4. And then you want to know 3/4 of what? So 3/4 of means multiply. So 3/4 of the total distance home. So 3/4 of L. Okay, the word of means multiply, and when you put a variable right up against a number, even though it's a fraction, you are multiplying when you put a variable up against a number. So this says 3/4 of L. Okay, if you're going to solve this, this would be just like on the previous page where you're trying to get rid of this entire fraction at one time. So just multiply by the reciprocal. And likewise on the other side, whether you're solving an inequality or an equation, you have to do the same thing on both sides. So here the 4's would cancel, the 3's would cancel. That's how you can get both the top and the bottom to go away at one time. Just multiply by the reciprocal. And then here it's 4 times 12 is 48 divided by 3. And then when you go 48 divided by 3, you can do it in your calculator if you'd like, you get 16. And that's in miles. So the length is 16 miles. Okay, just a few word type problems in that section. Then when you get to section 3.7, in section 3.7, it says write an equation that represents the total cost of ordering pizzas if the cost of each pizza is $9. Okay, we're going to use C for cost, and it's $9 times each pizza. And then they give you a table where you're filling in the values. These concepts were brought up in several sections in this chapter, and they come back again in 3.7. So if you wanted to use this equation to get all these answers, and then you can turn them into points, the answers that you're going to get. So for 0, it would just be C is equal to 9 times 0. Because this acts as the x coordinate, this acts as the y coordinate. So you just get 0. And you don't have to put the symbol there. When you write it as a point, it's going to be 0, 0. Okay, if you're doing 5, it would be C is equal to 9 times 5, which is 45. So $45. If you do the next one, and again, you could write it as a point. You plugged in a 5, you got a 45 for an answer using the pizza cost equation. If you were to go to the next number, you'd be plugging in a 10. So that gives you 90. Okay, at that point, you might want to notice, you could continue plugging into this equation, but there is a pattern here. This is going up 45 each time. This went up 45, this went up 45. And you can check one more of them if you want to by using the cost equation. Next number would have been 9 times 15, but you do get 135 when you multiply 9 times 15. And as you can see, what's happening each time here is that it is going up by 45. So if you just want to continue along in that pattern, you would just keep adding 45, or you can plug in the numbers one at a time here. So the number that went with 10, because these are all points that you can plot to create a graph. The 10 went with 90. So these are questions that will be asked on the test. You'll be asked to fill out a table, to create points from the table, and then you'll be asked questions regarding the values in the table. So if I continued this, noticing that there is a pattern, this would be 180, the next one. Then after that, it would be 225, all with dollar symbols. And then another 45 would be 270. Okay, then it says, are the points linearly related? Okay, what you check when you're asking whether it's linear related, that means when you graph it, will it be a straight line? You have to check the y column as well as the x column. So you see that on the y's, you have a consistent addition of 45 in between every two numbers, plus 45, plus 45, plus 45. Now also make sure, and you would actually show this for your work, and for the x's, You see that it's going up by the same number each time as well. That's what you're looking for, consistency in the number that it takes to get from one value to the very next value. And you see that it is a consistent plus 5. So if both columns, not just one, if both columns have consistency all the way down, as is the case here, then we say yes. These points are linearly related, which means if you went to graph them, like I just said, it would be a straight line. Okay, what is the slope? There's the formula for you right here. In all math books, we use the letter M when we're talking about the slope. And the slope is how slanted the line is. So if you were going to use this formula, you just need to grab 2 y values off the table and 2 x values. I think I'm going to go with these first 2 points because that way I'm using the smallest numbers possible. So 0, 0, that's one of the points I'm going to be using, and 545. I'm just going to go grab those so I don't have to keep looking up at the table. And now I'm going to use this formula. So it says subtract the y's. I'm going to go 45 minus 0 on the top. And then the formula says subtract the x's on the bottom. I'm going to go 5 minus 0. That gives me 45 on the top, 5 on the bottom, and that reduces to 9. So your slope is 9. Okay, what is the y-intercept? A y-intercept is a point on the y-axis, and it always comes in this form. Anything that's on the y-axis will have an x-coordinate of 0 and then a number back here. Now your y-intercept happens to be, there it is right in the table. When x is 0, you are talking about the y-intercept, and this is the actual y-intercept, the value in the y position. So off of the table, it looks like this. You know it's the y-intercept because the x value is 0, and this is your actual y-intercept. Usually these are 2 different numbers. So whenever you're trying to locate the y-intercept, just make sure that the number in the front is 0, and then the actual y-intercept is the number in the y position. So the b value is 0. Using the information that you got for slope and y-intercept, you can write the equation of a line. An equation that describes the line. And all you need to do is plug in slope and y-intercept, because the y and the x are present in the actual answer. So it's y is equal to slope times x, that's my slope, plus whatever you got for the y-intercept. So there's your equation of the line. If you want to clean that up a little bit, just because it can be simplified. Usually you can't, but this 0 plus anything, you can just write it like this. So you can give your final answer like this. If you give it like this, that's fine also. Okay, last question here. Now, write an inequality that describes the number of pizzas that can be bought for 175, assuming you can only buy whole pizzas, not a portion of a pizza. If you have 175, going with the information we've been given earlier on this page, that it's $9 per pizza. So you're going to spend this on as many pizzas as you can get, and you don't want to go over $175. So you want, this is the cost of this is your total cost for the pizzas. 9 times however many pizzas you buy. And that has to be either less than or equal to $175 because you just don't have any more than that to spend. So how many whole pizzas can you get? Divide, and you get P is less than or equal to, so 175 divided by 9, 19.4. Okay, since you can't buy a portion of a pizza, you're going to say that you can buy 19 whole pizzas. Say they don't sell portions of a pizza, which is true. Okay, that completes the problems on this page. One last problem is to take the information that you had from this problem, from the table, and to go and graph it. Okay, so use the information from the table to draw a graph with the number of pizzas on the x-axis and the total cost on the y-axis. Okay, so we'll label number of pizzas and cost. All right. Okay, so off of this table you had, I'm just going to plot the points. Excuse me. 0, 0. Now, if you're going to start plotting points, you should put some numbers on the x as well as the y-axis. So what you want to do when you're trying to come up with a graph and you're trying to decide on the scale for the x-axis and the scale for the y-axis is you just want to look at the numbers on the table. Like, for instance, the x's go from 0 to 30. So just make sure that whether you're calling it 2, 4, 6, 8, or 5, 10, 15, 20. Now, these jump in increments of 5, so I think that's exactly the scale I'm going to use. This will be 0, be 10, 15, 20, 25, 30. And then for the y values, which is really the cost, it goes from 0 to 270, jumping in increments of 45. So you could do that. You could call this 45. You could call this 90. $135, then 180, then 225, and 270. Okay, and then go plot the points. There was one point at 0, 0, which is right there. Then there was a point at 545, if you look at the points on your table. Then there was one at 1090. Then there was one at 15135, 2180, 25, 225, and 30, 270. And yes, we said they were linearly related because that's exactly what they create, a line. Okay, that concludes everything in 3.4, 3.5, and 3.7.